video, we are going to discuss about three-phase induction motor. So the first question is, what is motor? Motor is a machine which converts electrical energy into mechanical energy. This three-phase induction motor is an AC motor. Actually, this is required three-phase AC power, and this works on the principle of induction. Hence, this motor is called three-phase induction motor. Basically, there are two parts. The first part is called stator, second part is called rotor. As you know already, stator is nothing but stationary part of the motor and rotor is nothing but rotating part of the motor. Now we'll see the detailed construction of the stator. This is the stator diagram. As you know, the stator of the alternator and induction motor both are same. The outer part of the stator is called stator frame. This is made up of steel, and inner part of the stator is called stator core. It is made up of laminated silicon steel plates in order to reduce eddy current and hysteresis losses. And the stator core has many slots, so which carries armature winding. Actually, these windings are wound with particular number of poles. These poles actually decides the speed of the rotating magnetic field. That means the moment when AC supply is given to this winding, so this winding produces rotating magnetic field which rotates with the constant speed. Hence the name is called synchronous speed. The synchronous speed is calculated by using equation ns is equal to 120 f divided by p. Basically, there are two types of rotors are available in three-phase induction motor. The first rotor is called squirrel cage rotor. Second one is called phase wound rotor or slip ring rotor. Based on the rotor itself, three-phase induction motors can be classified like this: squirrel cage induction motor, slip ring motor, or phase wound induction motors. Now we'll see the detailed construction of squirrel cage rotor. 90% of the induction motors are squirrel cage rotor only. It has a cylindrical laminated core with parallel slots. These slots carries heavy copper bars or aluminum bars. It's not carrying any winding, instead of that which carries copper or aluminum bars. And these bars are welded at the end rings. So due to the welding of end rings, it is not possible to add any external resistance. Hence, the starting torque of this motor is less compared to slip ring induction motor. And one more point I have to say here, look at that, all bars are not parallel, they are skewed. The reason is, in order to reduce the humming noise and the magnetic lock tendency between the stator and rotor magnetic field, all these conductors are arranged in skew form. Now we'll see phase wound rotor. The phase wound rotor has winding instead of bars. In a squirrel case, it's having bar, but in case of phase wound rotor, it has winding. All these windings are connected to slip ring. On the slip ring, the carbon brushes are placed. So using these carbon brushes only, we can add external resistance to this star connected rotor winding. Star connection winding placed on the laminated rotor core. Open ends of the windings are brought out and connected to the slip rings. As I told earlier, these are called slip rings. Carbon brushes are resting on slip rings. External star connected rheostats are used as a star in order to reduce the starting current, which enhances the starting torque. And in the normal running condition, the slip rings are lifted above from the slip rings by using collar metal arrangement, which reduces the wear and tear between the carbon brushes and slip rings. Well, now we'll see the difference between squirrel cage and slip ring induction motor. The first difference is the construction part. The squirrel cage is simple. This is a complex because of slip ring, carbon brushes, metal collar arrangement. This makes construction is little complex compared to squirrel case. Second one is starting torque. The squirrel case having low starting torque, slip ring is having high starting torque because of that addition of external resistance. Speed control. It's possible but difficult. In the slip ring it's very easy because of that external resistance. The power factor of the squirrel case is very high, in the slip ring is low. In the cost wise, squirrel case is cheap, slip ring is costly, and efficiency of the squirrel case is low compared to slip ring. And maintenance is very less because construction part of this one is very simple compared to the slip ring. If I see that application point of view, as you know that 90% of the motors are only squirrel case, hence it is used in centrifugal pumps, industrial drives, large air blowers, fans, etc. And this having very high starting torque, hence it is uses in the lifting the loads like hoists, elevator, compressor, printing press, large ventilating fans.